Hey everyone, this video is to serve as a how-to guide for using the grill testing software. We're going to first go over what the application looks like and how it's laid out, and then we'll go into detail about how to use each of its features. For the first installation, both the LabVIEW resources and the testing software executable are installed. This first installation may take a few minutes. After the program is installed, there will be a folder placed on your desktop labeled Wood Grill, followed by the version of the testing software. In this folder is a shortcut to the testing software application. When first opening the application, the Routine Creator page comes up. We'll come back to this later once we've explored the primary testing features. So, from this Routine Creator screen, we begin by clicking Begin Test. This brings us to the main screen, where we'll be prompted to choose where to store log files, how many units to test, as well as their specific slave addresses, the communications port, and the sample period. There are two log files, one for events and one for data. I suggest that you make the default folders directly on your C directory. I'll come back to the log files after we're finished with our testing. The COM port selection is dependent upon where you've connected the RS-485 to USB converter. For my setup, the port is on COM 3. A good way to check for the correct COM port is to plug the USB device in, and then refresh the COM port list and see which COM port has been newly generated. For each instance of the testing software, we can monitor up to 4 different units. Each one of these units will need to be manually assigned a unique slave number at the controller. Remember, this is done by pressing the top 2 buttons on the controller at the same time, and then using the up and down arrows to select the address. The default sample period is the fastest period available, and for now, we'll leave that as is. Once we're set up, we press OK. If you successfully created the correct directories for the log files, the dialog box will disappear and you will be ready to begin testing. To the very left side, you will see some important information including how long the software has been running, the sample period, the communications channel, and the number of units under test. You also have the option to run a test or to exit the program. Note that while running a test, if you choose the exit button, the software will tell the controller to turn off. Once Run Test is selected, the control will be pulled at the data sample rate. At this point, the grill is not on. Along the top are 4 different tabs, one for each potential unit. If a unit is not being used, the data within that tab will be grayed out. The slave address of the current unit is shown directly under the Unit tab. Next to this is a drop-down menu for selecting which grill model the control is to run. To complete the selection of the grill model, we'll press OK. When this is done, the control will reinitialize its C parameters, which are listed in the table to the bottom right. The current grill model will be displayed in the model field next to the drop-down menu. The firmware version is also shown here. Within each unit tab, there are 2 sub-tabs. The first is for controlling the grill, the second for monitoring the grill. The gray outline command section is used to turn the grill on or off, turn the LCD on or off, select the run mode, and change a few other override features which we will cover later. To apply an actual change to the command parameters, the Apply Changes button needs to be pressed. We can remotely observe that the grill is on by looking on the Indicators page and checking what state the grill is in. bottom left of the indicators page, we see the current grill state as well as the selected mode of that state. Now let's go back to the Controls tab. Next to the Commands column, there's an option to select the display behavior parameters. These change how strongly the display temperature follows the measured grill temperature and how often the value on the screen is allowed to change. The countdown period shown here lets you manually assign the timer on the control. To make this timer actively turn the control off, we select the Stop on Countdown button to the left and choose to apply changes. The buzzer mode is currently a work in progress. The original intention was to allow for different buzzer features to be tested out. Below this small section are the override parameters. These allow you to manually enter duty cycle values while in the override mode. These values are between 0 and 100% with a 0.1% resolution. In order to enforce the overrides, the override mode must be selected, as well as the individual commands for each of the powered outputs. If we wish to apply these changes, we must hit the Apply Changes button. The variable control list has all C parameters listed on 2 pages. The current value column shows what is being currently read from the control. The desired value column is what you manually select to change the C value. To apply a change, we have to hit the OK button, followed by the Apply Changes to C variables. In this fashion, multiple variables can be changed at the same time. Now we'll go to the Charts and Indicators page. Here we have 2 different charts, one for temperatures and one for duty cycles. These charts will automatically scale the x-axis as time progresses. In each chart, we can select which traces we want to see. Under the charts is all the RTD info. If an RTD is valid, then the indicator light will be on for that RTD. A non-valid RTD is either short or open and will have a value of 0 for short or 2 to the 16th minus 1 for open. Also listed are the display temperatures, the adjusted grill temperature, the current set temp, and the countdown time if it's been assigned. Below the listed temperatures are indicators for the current duty cycle of the fan, auger, or igniter. Also, next to the duty cycle value is an indicator light that tells if the output is currently being powered. To the top right of the indicator screen is all information pertaining to automatic routines. When a routine is not being used, this section is not used. So right now, we're under the normal operating mode. Why don't we go into the override mode so we can observe what happens when we manually override parameters. Now that we have a feel for the base testing software, let's move on into the routine creator. In order to get there, we need to restart the application. On this routine builder page, we have three large buttons to the right of the text fields. The top two buttons save or load a routine. The routines are stored as CSV files. To run an automated routine, this toggle switch needs to be set to Run Routine. Note that the routines can be set for multiple units at the same time. For our first action, we'll turn on. Then we'll set the mode to normal. We'll wait for 1 minute after this step. Then we'll change the set temperature to 400 degrees F and wait for another 30 seconds. We also have the option to go into override mode. When selecting this mode, we only need to choose what the override duty cycles are. Now that we've generated a routine, we can save it to use it later or use it on other units. This is what it looks like when you go to load the routine. Now we'll actually run the routine on the main testing software. Again, we have to go through this setup. Let's begin the test. In the top right corner of the indicators page, we see the current step number, the action, how much time is left, what value we assigned, and how much total time is left in the routine. At any time, we can quit the testing by pressing exit. Now let's have a look at the data log and the event log. Inside the data log folder, you will see that each test has been recorded with its start time stamp. In each log, there is a start time and a unit slave number. Each data point is also time-stamped. Now let's have a look at the event log. The event log gives a breakdown of each important action that occurred, including the state or mode changes to the controller or changes to the C parameters. Alright, that's everything there is to the testing software. At the moment, there are a few known nuisances that we are working with EFE Labs to correct and improve. If there are any issues, requests, or general feedback, please let me know. Thanks for watching.